Atlas is not alone. A flock of comets have arrived into our inner solar system. What does this season of cometary activity mean for us here on Earth? What is 3I Atlas revealing about itself as it continues to release carbon monoxide, carbon dioxide, nickel, and now copious amounts of water? What have we learned and what can we potentially learn from this interstellar interloper?
The faint glow of 3I Atlas had been one of the most peculiar and captivating sights in the night sky. Astronomers marveled at it, not only because it was a rare interstellar visitor, an object that had journeyed across light years before brushing past our solar system, but because its trajectory and behavior seemed unlike anything seen before. Its sudden fragmentation, the moment it shattered into countless debris fragments, transformed fascination into shock. Now those fragments are no longer drifting harmlessly through the void. They are racing directly toward Earth, a cascade of interstellar rubble hurtling at incomprehensible speeds, and the implications of this event echo through science, society, and the very sense of our place in the cosmos. Before we start, smash the like and subscribe buttons for more updates. The story begins with 3I Atlas being identified as only the third confirmed interstellar object observed by humankind after Oumuamua and 2I/Borisov. Its arrival sparked immediate attention, and as with its predecessors, every telescope turned skyward to watch. The object exhibited an unusual brightness pattern, hinting at an unstable structure. For weeks, astronomers speculated whether it was icy, metallic, or perhaps even hollow. Those discussions ended abruptly when 3I Atlas suddenly shattered apart. Observatories recorded the event in real time, capturing the violent scattering of pieces that reflected sunlight like a swarm of shards flung from a cosmic explosion. The breaking apart was strange enough, but what made it extraordinary was the subsequent alignment of its debris on a trajectory intersecting Earth's orbital path. The debris is not drifting slowly. Traveling at tens of kilometers per second, every fragment carries colossal kinetic energy. Even pieces the size of cars or houses, should they reach Earth, would unleash destructive power akin to nuclear detonations. Larger fragments, stretching tens or hundreds of meters across, could devastate regions or cause planet-altering effects. Unlike meteoroid streams born of comets within our solar system, these are interstellar remnants, unfamiliar in composition and impossible to predict with certainty. Their alien origin adds an unsettling layer of mystery to the potential consequences. The physics of their journey amplifies the urgency. Interstellar debris moves faster than ordinary asteroids or comets. The sun's gravity accelerates their plunge, tightening their trajectory as they fall inward. With Earth positioned directly in the path, astronomers now calculate impact probabilities with increasing alarm. Some fragments may burn harmlessly in the atmosphere, creating luminous streaks across the skies and temporary meteor showers of breathtaking beauty. Yet others are too massive to disintegrate completely, promising impacts across continents, oceans, and critical regions of human habitation. The thin line between spectacle and catastrophe lies in the size and density of each fragment, details we cannot yet fully determine. Scientists, however, are captivated as much as they are concerned. For the first time, humanity confronts not a solitary interstellar visitor, but a whole storm of them. Each fragment is a messenger from beyond the solar system, carrying within it chemical secrets and physical structures from stars and planetary systems that may have formed billions of years ago. Analyzing even the smallest recovered piece could reveal untold insights into the chemistry of alien worlds. Laboratories are preparing to capture micrometeorites from this incoming swarm, hoping to study them as they scatter across the Earth's surface. The science is tantalizing, but it is shadowed by the reality that these samples are arriving violently in fire and thunder, not through careful collection. The human dimension of this looming event cannot be understated. People across the globe now live under skies that hold both wonder and dread. News outlets broadcast simulations of glowing fragments streaking through the atmosphere, while scientists provide carefully worded assessments of risks. Governments scramble to prepare defense systems, though the speed and unpredictability of interstellar debris make interception almost impossible. Unlike near-Earth asteroids, which follow predictable orbits and can sometimes be nudged away with enough warning, this torrent of interstellar rubble offers no such luxury. The window of action is narrow, and technology, for all its brilliance, struggles to catch up. As the fragments hurtle closer, attention also turns to the philosophical implications. For centuries, humanity has gazed at the stars with curiosity, searching for signs of other worlds and pondering whether we are alone. The shattering of 3I Atlas and the direct impact of its remnants brings the vastness of interstellar space into stark and immediate relevance. It is no longer a distant dream or academic thought experiment. It is a confrontation with the reality that we live in a cosmic environment where events from beyond our solar system can suddenly intrude with profound consequences. The illusion of separation from the wider galaxy has been broken as thoroughly as the interstellar visitor itself. The debris racing toward Earth also reshapes scientific debates about the nature of interstellar objects. Was 3I Atlas a fragile, icy comet-like body that crumbled under thermal stresses? Or was its destruction triggered by internal processes, such as volatile gases trapped within an alien structure? Some theorists even raise the possibility of artificiality, given its unusual brightness behavior before shattering. While evidence leans toward natural origins, the questions linger, especially now that fragments will soon arrive to offer physical proof. Whatever its nature, its breakup has ensured that interstellar exploration is no longer an abstract field, but a pressing, urgent study thrust upon humanity. Communities look upward with mixed emotions. In some regions, clear skies allow glimpses of faint moving points of light that are pieces of this fragmented visitor. Amateur astronomers share images online, mapping the growing swarm as it approaches. For many, it is awe-inspiring, a reminder of the grandeur and unpredictability of the universe. For others, it is terrifying, a looming threat that transforms the night sky into a harbinger of danger. The psychological impact alone marks this as one of the most extraordinary astronomical events in recorded history, not just for what may physically happen, but for how billions of people feel united under its shadow. In the scientific community, preparations intensify. Radar systems track the largest incoming chunks, while satellites monitor their paths. Researchers calculate potential impact zones, though uncertainties remain vast. The possibility that several large pieces could land in oceans raises concerns about tsunamis, while land strikes might devastate cities, forests, or farmland. Yet even as simulations highlight catastrophic scenarios, there is recognition that many fragments will simply add to Earth's atmosphere in harmless showers. The contrast between harmless beauty and destructive force encapsulates the paradox of this event. The same shards that could create fiery trails across the heavens might also carve craters into the surface below. The anticipation of their arrival has sparked a renaissance in planetary defense discussions. Agencies around the world, from NASA to ESA to private spaceflight companies, now face a test of imagination and engineering. Could humanity one day deflect interstellar debris, just as it plans to for asteroids? Could we design shields or interceptors capable of responding within days or weeks rather than decades? Though too late for this event, the challenge posed by 3I Atlas may catalyze future innovation, compelling humanity to evolve its defenses against the vast uncertainties of the cosmos. In that sense, the shattering may be not only a threat but also a catalyst for growth. There is also the cultural resonance of this moment. Throughout history, comets and meteors were seen as omens, symbols of change, or divine messages. Now, in the modern age of science and technology, a shattered interstellar visitor reawakens those ancient feelings. Poets and artists capture the imagery of alien fragments blazing across the sky, while communities gather for vigils under the stars. The event is interpreted in countless ways, yet the shared experience unites humanity in collective awe. The sky, once a realm of constancy, now becomes a stage for drama that transcends borders and ideologies. The approach of 3I Atlas debris highlights how interconnected human life has become. Satellites, navigation systems, and communication networks all stand vulnerable to even small fragments colliding in orbit. A single piece the size of a pebble but moving at interstellar speed could disable critical infrastructure. Engineers brace for potential disruptions, preparing contingency plans for systems that modern society depends on daily. The event, therefore, is not only about craters or fireballs, but about the delicate web of technology stretched around our planet. The interstellar shards threaten to test the resilience of a civilization that has extended itself into the heavens. As the countdown continues, the skies will grow increasingly dramatic. The first signs may be faint meteors flickering as grains of interstellar dust skim the atmosphere. Then, larger streaks of fire will cross the night, illuminating landscapes and startling witnesses. These will be the harbingers of greater fragments to follow. People across the globe will look up, capturing images, sharing videos, and experiencing in real time the arrival of material that has traveled perhaps billions of years through the void to meet Earth in a fiery embrace. The anticipation of that moment grips the imagination like few events ever could. It is not simply about risk or danger, but about perspective. 3. I-Atlas, in its shattering, has delivered a message of scale. We are small on the cosmic stage, vulnerable to events that unfold far beyond our control. Yet we are also capable of perceiving them, understanding them, and perhaps in the future defending ourselves against them. The interstellar shards racing toward Earth embody both fragility and resilience. Fragility in the face of cosmic forces, resilience in the human spirit to face them with curiosity, science, and imagination. The days and weeks ahead will be remembered as a turning point. Whether the fragments bring devastation or only dazzling displays in the sky, they have already changed the narrative of humanity's relationship with the universe. No longer are interstellar visitors merely distant curiosities. They are active participants in our story, capable of altering landscapes and futures. The shattering of 3 I-Atlas has bound us to the wider galaxy in a way no telescope or spacecraft yet has. Its debris is not just approaching Earth, it is reshaping how we see ourselves beneath the stars. The sudden disintegration of 3 I-Atlas did more than scatter fragments across space. It also scattered certainty. When astronomers witnessed the event, their calculations of orbital trajectories shifted rapidly. What had been a singular object moving through the solar system in a predictable arc became a diffuse and expanding cloud of bodies, each with its own velocity vector and rotational spin. The task of tracking them all required a global coordination of observatories, radar arrays, and space-based telescopes. Every fragment, from pebbles the size of a coin to massive slabs hundreds of meters wide, became its own problem to solve. This act of celestial fragmentation turned into one of the most intense exercises in collaborative astronomy the world has ever seen. The difficulty lies in the behavior of interstellar debris. Unlike near-Earth objects born from familiar orbits, these pieces carry velocities influenced not only by the sun's gravity, but also by countless gravitational interactions across their ancient journey. Some fragments tumble chaotically, reflecting light in erratic ways that confound measurements. Others appear darker, coated in alien compounds that absorb rather than reflect sunlight, rendering them nearly invisible against the starry backdrop. The search to locate, categorize, and predict the paths of these remnants becomes as much about patience and pattern recognition as about raw data. Even with cutting-edge computing models, uncertainties remain wide, with some predictions carrying margins of hundreds of kilometers. Such gaps mean that nobody can say with confidence exactly where or when the largest fragments will appear. The anticipation has ignited a revolution in how humanity organizes its observational efforts. Amateur astronomers, once relegated to the sidelines, now play a pivotal role. With so many fragments to track, large institutions cannot cover all the skies at once. Backyard telescopes connected to global networks feed data into shared servers, creating a distributed web of eyes on the heavens. This democratization of observation underscores a profound reality. The universe does not discriminate between professional and amateur. All eyes can witness, and all voices can contribute. The shared urgency erases barriers, weaving together an unprecedented collaboration of humanity's curiosity and survival instinct. At the same time, laboratories around the globe scramble to prepare for the possibility of collecting fresh extraterrestrial material. Specialized facilities designed for handling meteorites now anticipate samples unlike anything previously encountered. Interstellar debris, untouched by the solar system's radiation and chemical environment, represents a pristine archive of alien chemistry. The possibilities are staggering. Some fragments may contain exotic isotopes formed in stellar furnaces different from our sun, Others may carry molecular structures forged under conditions never found in our system. The prospect of holding such matter in human hands for the first time electrifies researchers. Yet this enthusiasm is tempered by the sobering truth that these samples will not arrive gently. They will slam into Earth with energy sufficient to vaporize or transform their structure. What survives will be altered, fractured, and partially destroyed, leaving researchers to reconstruct what was lost. Beyond the scientific scramble lies a cultural upheaval. The shattering of 3Y Atlas has infiltrated art, philosophy, and religion in ways few astronomical events have managed. Painters and digital artists flood galleries and online spaces with depictions of the incoming swarm, blending realism with abstraction to capture the raw tension of the skies. Musicians compose symphonies inspired by the imagery of light streaking through darkness. Religious leaders interpret the event through their own lenses, some seeing it as a warning, others as a sign of divine magnitude. Philosophers draw parallels between the shattering of this cosmic traveler and the fragile nature of human existence. In coffee shops, lecture halls, and online forums, the debris becomes a metaphor for impermanence, change, and the unpredictable forces that shape life. Meanwhile, policymakers confront dilemmas that test the limits of governance. The arrival of extraterrestrial debris is not an issue that respects borders. Impact zones, whether in deserts, cities, or oceans, will have global implications. Food security, communication, transportation, and energy grids could all be disrupted by strikes in key areas. Governments face the impossible task of preparing for an event whose exact details cannot be predicted. Some call for massive evacuations of projected zones, while others argue for calm, fearing panic more than impact. International agencies attempt to mediate, but the sheer scope of uncertainty leaves most decisions paralyzed. The event forces humanity to confront the tension between collective action and national interest, between transparency and secrecy, between preparation and paralysis. The military dimension adds another layer of complexity. Defense agencies quietly explore whether existing missile systems could be repurposed to intercept the larger fragments. Tests are run in simulations, but results reveal sobering truths. At the velocities involved, even advanced interceptors may lack the precision needed to shatter or deflect the objects. Worse still, fragmentation may not help. Breaking a large piece into smaller ones could increase the number of potential impacts rather than reduce them. The dilemma mirrors the challenge astronomers faced when 3I Atlas itself fragmented. Multiplication of threats rather than their reduction. The event reveals the limits of human technology against the vast, indifferent mechanics of the universe. As public attention intensifies, the role of media becomes crucial. Sensational headlines warn of impending catastrophe, while calmer scientific voices attempt to inject nuance. Documentaries rush into production, promising to capture every stage of the debris' approach. News outlets broadcast simulations of fiery trails across familiar skylines, raising both awareness and anxiety. The global population, long accustomed to seeing natural disasters localized to regions, now confronts a truly planetary concern. Unlike hurricanes or earthquakes, whose destruction is confined to specific geographies, interstellar debris threatens everyone equally. That universality alters the narrative. For the first time, all of humanity shares a single celestial countdown. Educational institutions seize the moment to engage students in astronomy and physics. Schools hold late-night skywatching sessions, turning rooftops into classrooms under the stars. Children who once memorized constellations now learn orbital mechanics, discussing escape velocities and impact probabilities. Teachers encourage projects where students model trajectories using simple physics, connecting classroom equations to the very real drama unfolding above. The event fosters a generation of young thinkers inspired not only by the spectacle but by the tangible relevance of science in understanding and confronting existential challenges. In this way, the shattered interstellar visitor becomes an unlikely teacher, shaping the next wave of curiosity and resilience. The economic dimension of the event cannot be overlooked. Markets react sharply to uncertainty, with insurance companies reevaluating risk models. Shipping industries consider rerouting vessels away from projected oceanic impact zones. Airlines prepare for potential airspace disruptions should fragments enter at altitudes that threaten aircraft. Technology companies, reliant on satellites for communication and navigation, brace for the possibility of orbital debris collisions. The cascading effects of such uncertainties ripple through global economies, underscoring how deeply intertwined modern life is with both space and stability. Economists warn that even if impacts prove minor, the psychological shock alone could alter consumer behavior, investment patterns, and trade flows for years to come. There is also a quieter, more intimate side to the event. Families gather under night skies, watching for the first visible fragments. Children ask parents if the glowing trails are dangerous, and adults struggle to answer with both honesty and reassurance. Couples sit together on balconies, sharing the rare experience of knowing they are part of a moment both historic and uncertain. Communities host gatherings to watch the skies collectively, turning fear into solidarity. Around campfires, in city parks, and on rural plains, people look upward and remember that despite differences of language, culture, and belief, they share one fragile planet beneath an immense cosmos. In scientific circles, debates intensify about the origin of 3Y Atlas before its arrival in our solar system. Where did it come from? Which star system birthed it? Some suggest it may have originated in a young stellar nursery, ejected by gravitational interactions with giant planets. Others argue it was once part of a shattered world orbiting a dying star, hurled into interstellar space during cataclysmic upheaval. Its composition may carry the fingerprints of that history, ratios of isotopes that reveal ancient stellar processes, or minerals forged under conditions alien to our solar neighborhood. Every fragment holds the potential to answer questions humanity has pondered for centuries. How common are planetary systems? How diverse are their chemistries? Could seeds of life travel across the galaxy on such fragments? The shattering of 3I Atlas thus promises to be not only a threat but a revelation. As anticipation builds, artists and writers attempt to capture the emotional weight of the moment. Novels emerge almost overnight, imagining parallel worlds where the debris brings utopia, apocalypse, or transformation. Filmmakers rush to dramatize scenarios of impact and survival. Theater productions use metaphor and allegory, presenting the shattered interstellar visitor as a mirror of societal fragmentation and resilience. Humanity, confronted with the raw indifference of the cosmos, turns inward to reflect on meaning, purpose, and the delicate balance between awe and terror. The event becomes not only a physical reality, but a cultural touchstone, weaving itself into the collective imagination of the era. For scientists, one of the greatest challenges lies in distinguishing between fragments that will threaten Earth and those that will miss entirely. As the cloud of debris spreads, gravitational influences from Jupiter, Saturn, and even the Earth-Moon system constantly adjust trajectories. Some fragments may slingshot harmlessly away, while others may shift unexpectedly onto collision courses. The constant recalculations demand both precision and humility, as no model can fully capture the chaotic complexity of such a scenario. In this uncertainty lies both frustration and fascination, the recognition that, despite humanity's progress, the universe retains mysteries that resist mastery. Another frontier opened by the event is the potential for technological innovation. The prospect of capturing small fragments in the upper atmosphere inspires engineers to design new collection devices, such as balloons or drones, fitted with specialized materials to trap micrometeorites. Others propose missions to launch small spacecraft that could intercept fragments before they reach Earth, scooping samples from space itself. While these projects may not come in time for the current event, the urgency of 3Y Atlas accelerates funding and research into such ideas. In the long arc of history, the shattering may be remembered not only for its immediate consequences, but for the technological leaps it inspired. The psychological dimension is equally profound. Humans, accustomed to thinking of the sky as a realm of constancy, now confronted as a source of imminent change. Sleep patterns shift as people stay awake to watch the night sky. Anxiety spreads, manifesting in both quiet dread and heightened creativity. Psychologists note parallels with other collective stress events such as wars or pandemics, but also observe unique features: the universality of the experience and the impossibility of control. Unlike a political conflict or a biological outbreak, the interstellar debris is beyond negotiation or containment. The recognition of this helplessness fosters both despair and resilience, compelling individuals and communities to adapt emotionally in ways never before required. What makes the shattering of 3I Atlas especially significant is that it is not merely a passive event. It demands interaction. Humanity cannot simply watch, it must calculate, prepare, respond, and interpret. The debris challenges scientific institutions, governmental structures, cultural frameworks, and personal imaginations simultaneously. It forces humanity to see itself as part of a dynamic, unpredictable cosmos, subject to forces far larger than national politics or technological ambition. This confrontation, though born of danger, may ultimately deepen humanity's sense of unity and perspective. As the fragments draw closer, anticipation builds to a fever pitch. Every streak of light across the night sky is scrutinized. Every unusual flash in the atmosphere sparks discussion. The countdown is not measured in hours or days alone, but in emotions, hopes, and fears. Humanity waits at the threshold of an encounter unlike any before, knowing that soon, the alien shards of a shattered interstellar traveler will meet the Earth. What they bring, knowledge, beauty, destruction, or transformation, remains uncertain. What is certain is that this event has already altered how humanity perceives the universe and its own fragile place within it. The spectacle of 3I Atlas shattering has not only galvanized the world of science and culture, but also opened entirely new avenues of thought regarding interstellar phenomena and Earth's vulnerability. One of the most striking realizations stemming from this event is the recognition that humanity's understanding of cosmic hazards has been far too narrow. For decades, planetary defense focused almost exclusively on near-Earth asteroids and comets, bodies that could be tracked, cataloged, and sometimes even deflected. The arrival of debris from beyond the solar system forces a radical expansion of perspective. Now, it is no longer sufficient to look inward at our own celestial neighborhood. The gaze must extend outward into the wider galaxy, where countless unseen bodies drift, any of which could one day cross Earth's path. This awareness has ignited an emerging field: interstellar hazard studies. Teams of astrophysicists are already drafting proposals for new observatories positioned in deep space, far from Earth's atmospheric interference, designed specifically to detect faint objects moving at interstellar velocities. Unlike conventional telescopes, which often focus on stable orbits and long-term tracking, these instruments would prioritize identifying transient high-speed visitors before they enter the solar system's interior. The dream is to build an early warning system capable of decades, not weeks, of notice. Such initiatives may represent the beginning of a new era in space science, one where humanity accepts its vulnerability and chooses vigilance on a galactic scale. A related development is the rising conversation about planetary stewardship in light of cosmic unpredictability. The shattering of 3I Atlas reminds us that Earth's safety is never guaranteed. Just as earthquakes and volcanic eruptions shape the planet's history, so too do cosmic impacts loom as agents of sudden transformation. Recognizing this, thinkers in environmental and ethical fields argue that humanity's responsibility is not only to safeguard ecosystems from human damage, but also to prepare them for extraterrestrial threats. This includes developing resilient agricultural systems that can withstand atmospheric disruptions, diversifying energy sources to survive potential grid collapses, and building global food reserves capable of withstanding years of climatic uncertainty following an impact winter. In a strange way, the debris of 3I Atlas serves as a stark teacher. Resilience must be planetary in scale. The scientific opportunities, however, extend beyond planetary defense. The incoming fragments are not merely hazards, but also probes. Each one is a piece of a world that once orbited a distant star, torn free and sent wandering across the interstellar medium for millions, perhaps billions of years. If captured or recovered, they could provide an unparalleled record of alien chemistry. Consider the tantalizing possibility that some fragments might contain preserved organic molecules, building blocks of life that formed under conditions utterly foreign to our own solar system. The discovery of such compounds could transform our understanding of life's potential in the galaxy. Even if no such evidence appears, the isotopic ratios alone, signatures of the stars that forged their elements, will provide data about stellar environments far removed from our neighborhood. These considerations push space agencies to rethink their mission priorities. Proposals begin circulating for rapid response spacecraft, designed to intercept incoming interstellar debris within weeks. Such missions would not attempt deflection but rather reconnaissance, sending back high-resolution images, spectra, and perhaps even physical samples. Although current technology may not allow for immediate execution, the urgency generated by 3I Atlas ensures funding will accelerate. Much as the launch of Sputnik catalyzed the space race, the shattering of this interstellar traveler may catalyze a new race. One not of nations competing, but of humanity collectively striving to understand and coexist with the unpredictable universe. The philosophical dimensions deepen further when considering the concept of cosmic randomness. For centuries, human societies have tried to impose order on their environments, building walls against floods, forecasting weather, and engineering technology to mitigate natural hazards. Yet, interstellar debris ignores such efforts. Its arrival is indifferent, unprovoked, and uncontrollable. Philosophers describe this as a confrontation with the sublime, the realization that there exist forces beyond comprehension or mastery. The shattered visitor challenges anthropocentrism, reminding us that the Earth is not the stage upon which the universe revolves, but rather a small participant in an unfolding cosmic drama. This recognition, while unsettling, also carries a strange beauty. It reconnects humanity with humility, a quality often overshadowed by technological ambition. In literature, the event is already spawning a subgenre of cosmic realism. Writers weave stories where interstellar debris becomes a symbol for sudden change, unpredictability, and the intertwining of fate and chance. Some tales explore how societies confront looming uncertainty, while others imagine characters who find transcendence in the shimmering trails of alien dust across the sky. This literary wave emphasizes how the event is not confined to laboratories and observatories. It resonates in the human psyche, shaping narratives of identity, meaning, and destiny. The debris becomes a mirror in which humanity sees both its fragility and its resilience. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I Atlas shattering into dangerous debris? We want to hear from you. Thank you for watching, and see you next time.